Right now, nearly every major corporation is rushing to integrate generative AI into their daily operations to cut costs and speed up production. This chart shows the scale of that rush. The global market for this technology is on a massive upward trajectory, projected to climb toward $440 billion by 2032. But there is a roadblock stalling that growth. Large language models operate as black boxes, meaning they often reach conclusions through hidden processes that humans can't verify. For businesses, this leads to a fatal flaw. The AI can confidently hallucinate false information. This unreliability often starts at the technical foundation of how AI reads. Standard AI tokenizers are designed for 1-byte English letters, but when they process non-English languages, like a 3-byte Korean character, the data is jaggedly sliced apart into uneven fragments. Because the AI is forced to process these broken pieces, it frequently misinterprets the context. It reassembles the data incorrectly, leading to errors that can be dangerous in a professional setting. For a manufacturing plant or a defense agency, an AI that is only 80, their solution began with Xservice, a platform built to find specific hidden connections in the dark web without relying on basic keyword searches. The first pillar is ontology, a rigid rulebook teaching the AI exact definitions and hierarchies of specific fields, like chemical precursors or encryption methods. The second pillar is the knowledge graph, a visual map connecting those concepts to surface hidden relationships human analysts miss. Think of a standard LLM as a high school student with a broad but shallow range of knowledge. S2W's model is more like a college graduate with a degree in a highly technical, specialized field. By combining ontology and knowledge graphs, S2W transformed a guessing machine into a reasoning machine, where every data point is mapped and verified in context. S2W is now applying the same architecture they use to map dark web crime syndicates to resolve the corporate black box. They developed SAIP and Quaxar, enterprise and security platforms designed to bring this domain-specific technology to the corporate world. At Hyundai Steel, for example, S2W used an ontology to teach the AI the exact hierarchy of the plant's casting and cooling processes. Understanding the factory floor's specific language surged the system's accuracy past the 80% standard, reaching over 95%. This creates explainability. Human operators can use the knowledge graph to trace every logical step the AI took to reach its conclusion. By applying dark web intelligence to industrial data, S2W has created an AI that can finally show its work to human supervisors. This places S2W in direct competition with American giants like Palantir. But while those companies offer similar high-level intelligence, they come with a massive barrier to entry. Legacy systems often require big bang implementations, expensive, multi-month overhauls requiring massive engineering teams to build data structures manually. S2W uses a more modular approach. Highly automated technology allows them to deploy specific blocks of intelligence quickly and at a much lower cost. This agility has led to adoptions by Interpol, the Singapore government, and various defense agencies throughout Asia. This modularity allows mid-size firms and regional governments to deploy high-level intelligence without the massive engineering teams and billion-dollar budgets required by larger competitors. We are moving past the era where users type a single prompt into a chatbot and wait for a text response. S2W's endgame is a multi-agent environment that changes how organizations actually function. In this future, specialized AI agents for supply chains, diagnostics, and scheduling talk directly to each other to solve complex problems autonomously. This teamwork works because the knowledge graph provides a shared factual framework. Speaking the same structured language, they don't hallucinate. Industrial AI is moving beyond simple word prediction. S2W has built the transparent, controllable engine required to power the high-stakes industries of tomorrow.